We now learn how to find a line's equation given the coordinates of two of the points through which it passes. Now, before we actually learn the method, let me highlight something important. When we're looking for a line equation, we are always seeking to find an equation looking something like this. Y equals to m times x plus c, where m is the gradient of the line, also known as the slope, and c is the y-intercept of the line, and that's equal to the y-coordinate of the point at which the line cuts the y-axis. When we look for a line's equation, we always do things in the following order. The first thing we look for is the gradient, and in fact that will be the first step in the method we're going to learn. The second thing we look for is the y-intercept, and that will be the second step in the method that we'll learn. But keep that in mind. The first thing we find is always going to be the gradient, and the second thing we find is the y-intercept. Now that that's said, let's go ahead and learn the method with a worked example. We're asked to find the equation of the line passing through the points with coordinates -1, -5, and 4, 5. Well, before doing anything, the best thing to always do, whether or not it's asked in a question, is to make a quick sketch of what the line looks like. So let's start with that. Let me throw in some graph paper here. Okay, I've got my gridded paper here. So, a quick sketch. I'll just quickly draw some x and y axes. So this is my y-axis that I'm drawing right now. And here's my x-axis. Now notice that I'm not even using a ruler. I'm only seeking to get a rough idea of what the line looks like. Now the first point we were given had coordinates -1, -5. So starting from the origin, that's 0, I go 1 to the left, that's -1, and 5 units downwards, that's 1, 2, 3, 4, 5. So the first point is this point right here. The second point the line passes through has coordinates 4 and 5. So that's 4 units across, so that's 1, 2, 3, 4. And 5 units upwards, that's 1, 2, 3, 4, 5. So the second point is this point here. Now the line whose equation we need to find is the following. It's a line passing through these 2 points, something like this. And notice that this line isn't drawn with a ruler. Don't let that bother you. This is a very rough sketch. Now here's why doing this is useful. It gives me a couple of things to look out for when looking for this line's equation. We can see going from left to right that this line is going upwards, and that tells us that the gradient of this line must be positive. In other words, simply by looking at this sketch, we already know that the gradient m must be greater than 0. And this is useful. If ever in our working we were to find that m is negative, then we must have done something wrong, and we should go back and check our calculations. This sketch alone allows us to tell that the gradient has to be positive. The second thing that this sketch allows us to do is to get an idea of what the y-intercept should be. Remember, that's the y value at which the line cuts the y-axis. Now, looking at this rough sketch here, it seems that the y-intercept is roughly -3. So I'm going to go ahead and say that c should equal to -3. Now, this doesn't necessarily mean that the y-intercept has to be -3. Indeed, this is a rough sketch, but it does nevertheless give us a rough idea of what it should be. Okay, now that we've done that, let's go ahead and learn the two-step method for finding a line's equation. Let me just move this sketch to the side here. There we go. And now let's get started. Remember, we're looking for a line equation, so what we're after is something looking like this. Y equals to m times x plus c. And the first step, step 1, is to find the gradient. Now we find the gradient using the gradient formula, and the gradient formula is the following. M equals to y2 minus y1 over x2 minus x1. where x1, y1 correspond to the coordinates of one of the points the line passes through, and x2, y2 correspond to the coordinates of the other point that we know of. Looking back at the question, we were told that the line passes through the points with coordinates -1, -5, and 4, 5. So we can go ahead and call this first point -1, -5, point 1, and we'll call the other point 4, 5, point 2. Now it really doesn't matter which one we call point 1 and which one we call point 2. We could have done this the other way around. Personally, I tend to always simply call the first one I read point 1 and the second one I read point 2. Now what this means is that -1 is x1 and -5 is y1, and 4 is x2 and 5 is y2. So using those coordinates in the gradient formula leads to the following. M equals to y2 minus y1, so that's 5 minus -5, over x2 minus x1, so that's 4 minus -1. That's 4 minus -1. We now calculate. Now keep in mind that when we subtract a negative, it turns into an addition. We have on the numerator 5 plus 5, and on the denominator 4 minus -1, that's 4 plus 1. That leads to 5 plus 5, which is 10, over 4 plus 1, which is 5, and finally m is equal to 10 over 5, which is 2. So that's the gradient, and we can go ahead and box that result. That's our result of step 1. Now at this stage, the end of step 1, we know that this line equation, the one we're after, has to look something like this. Y equals to 2 times x plus c, where this 2 is the gradient that we just found. We can now move on to step 2. And in step 2, we find the y-intercept. To find the y-intercept, our starting point is to look at what the line equation looks like at the end of step 1. That was y equals to 2x plus c. So I'll just write that here. We know that y must equal to 2 times x plus c. Now we choose either one of the 2 points that we were given in the question. That is, we choose either -1, -5 or 4, 5. And it actually doesn't matter which of the 2 points we choose, but it is worth making our lives as easy as possible. So looking at these 2 points, we need to ask ourselves, which of the coordinates would we rather work with? Well, looking at these, we have -1 and -5, or 4 and 5. To avoid sign errors, if possible, I tend to always take points which have positive coordinates. So in this case, that would be the point with coordinates 4 and 5. So I'll choose that one, and I'll write use 4 and 5. Now, to find c, all we have to do is to replace the x in the line equation by the x-coordinate of the point we just chose, and the y in the line equation by the y-coordinate of the point we just chose. That would look like this. 5 equals to 2 times 4 plus c. All I've done there is replace y in the line equation by 5 and x in the line equation by 4. And that's how we get this. Now we calculate. 5 equals to 2 times 4, which is 8, plus c. And now we can see that we have an equation for c. The only unknown is c, and we can rearrange this to find its value. All we have to do is subtract 8 from each side of this equation. That's 5 minus 8 equals to c. And 5 minus 8 is -3, so -3 equals to c. Finally, c is equal to -3. And we now have the y-intercept. And we can now state this line's equation. That is, y equals to 2x minus 3. And that's the final answer. Comparing this line equation to the initial sketch we had made, this seems to work. Indeed, we had seen that the y-intercept had to be roughly -3, which is exactly the y-intercept that we have in our line equation. And we had seen that the gradient had to be positive. And indeed, 2 is a positive gradient. And there we have it. That's how to find the equation of a line given the coordinates of two of the points through which it passes. And that's it for this tutorial. There we go, everyone. I really hope that helped, and if it did, please hit like on this video and even subscribe to our channel because that really does help us. I'll see you soon.